Hello, friends. Today we are back with a new topic. So, today's topic is writing some text in the Carla, like near the car, using a radar sensor, of course. So, hi, friends. I'm Mohnish, and you're watching Codex-Mohnish. So, let's get started with a code. So, I'll open my Sublime text, my code editor. So, as always, we are importing libraries. We are getting the Carla. We are importing Carla, actor list. We are like this code was explained in the last class, like last video. So you can last see the last video and you can understand what this code means. So, and here we are calling a client. We are trying to load the Kala, and I'll just give you a brief description. So this is a radar sensor. So radar sensor will have a few attributes, which are horizontal FOV, vertical FOV, points per second, and range, which are explained in the video. So you can see that. And we are getting the blueprint of the world. We are spawning the car, camera. We are generating the radar sensor. We are setting the spawn point of the radar sensor and we are attaching it to the drop vehicle. So drop vehicle is the vehicle which we are spawning. You see the vehicle like variable. And when listening to the radar data, we are calling the radar data function like callback function, like radar callback function, and we are sending the parameter radar data. So, but what is this listen function? Like, I'll just give you a brief about this. So, sensor is our sensor. You see sensor world.spawn. So, this is a sensor, and sensor will return us data. Like, a radar sensor has different data which is returns. LiDAR has different. Semantic LiDAR has different data. Then depth sensors, camera RGB, like, and there are many types of sensors. And if we talk about sensors, it can be hours of talk. So we'll just end it here. And so it will try to listen, like listen is like getting the data. And we're calling a lambda function. Like it's not necessary like we need to call a lambda function, but then also it's easier. Like we don't know like which variable we are going to get the data. So we are just assigning that data to the radar data variable. And we are calling a lambda function with the radar data as the like argument. Like it will be taken from the sensor or listen, like this will be a variable and we are calling the radar data like radar callback function and we are sending this as a parameter argument. So like this is a function, so these are like the data you need to call the function. So lambda is a function and this is the parameter like which you need to run the function, like which we are getting from the sensor or listen, and we are calling what we need to do. So it doesn't need, and we are calling the radar callback function. We can also print something. So we can't do multi-line things here, only single line functions in lambda. So that's the thing. And we are calling the radar callback function. So radar callback function is our interest of today. So let's get started. So radar current rotation equals to radar data dot transform dot rotation. So we are storing the current rotation like yaw, pitch, and all that. Roll, yaw, pitch of the camera like radar in the radar current rotation variable, and we are getting that rotation from the radar data. So the radar data dot transform dot rotation. So we get it like this. So radar data is this data which you are getting from the sensor or listen, and we are calling debug dot world dot debug. So that's it, and that's very simple. So what's the world dot debug? So net is always a better place to search sometimes. So debug mode actually you won't find much data about it like in world dot debug and Carla. So you have a full document in it, so you can read this document and you can know what is world dot debug. So you see debug world dot debug debugging. The world objects have a Carla debug help object as public attribute. It allows for different shapes to be drawn during the simulation. So these are used to trace the events happening. The following example will draw a red box. So we are calling the debug so we can draw things. So it's very simple. But if you want to get more information, you can read the whole documentation page, which I will be not reading right now. So for detect, so like I think the variable would make sense if it was detection, but okay, for detect in radar data. So we have four parameters, like not parameters, like four values which are returned by radar sensor, which are azimuth, altitude, velocity, and depth. So depth is the distance, velocity is velocity. But what is azimuth in? Okay, I'll just Google this again. Okay, radar azimuth in Carla. Azimuth in radar. So azimuth resolution describes the ability of an imaging of radar to separate two closely spaced scatters in a direction parallel to the motion of vector of the sensor. So this is like kind of tough to understand, but you can just see the elevation angle. Like is the you can think that of the angle at which the road and the sensor is. So sensor is placed at the car. So with that we are getting the azimuth as elevation. We are calculating it. So we also have a zenith 90 and north 0. Azimuth is the rotation at the road. So you can see the road rotation, and you can that's what azimuth is. And altitude is what it seems like. Altitude. Yeah, altitude in radar. So altitude is the height, of course. So this will give you the angle from the road, the azimuth, you can say, and altitude will give you the height from the road. So it's very simple. Like if you think I was confusing for a second, so you can just pause the video, rethink, rewind it, and watch. Then we are calling the rear view, like rear view equals to Carla dot vector 3D. So vector 3D is a function, like, and we're calling x equals to minus detect dot depth minus 1. So what we are doing from the detect dot depth, detect is our radar data, like for now, like there are many data collected at the same time, like so much data. From that we are taking one by one. So we are making a 1, we are minusing it 1, and we are making it minus totally. So the whole thing will get backside the car, back of the car, rear view of the car. New pitch, new raw, new roll is we are adding the altitude for the pitch, yaw, and like pitch we are adding altitude, yaw we are adding azimuth, and roll is roll. Like that's it. So if you want to know what are these, so pitch, raw, pitch, yaw, roll in camera. Like you would get the best image here. So I like this image. Like you understand what is this. So roll is like this from the lens, pitch is like full uh, by the body, and yaw is like the direction. Okay, so that's very simple. And uh, Kala dot transform, we are setting the Kala dot location and Kala dot rotation. Here we are using directly Kala because radar sensor is the thing we are working with. You know, Kala is smart. So pitch equals to new pitch, yaw equals to new yaw, roll equal to new roll, and we're transforming. Like yes, where are we where we want this thing to happen? In the rear view, of course, and debug. So debug is our variable, world.debug dot draw string. We are going to draw a string now. So write text here. This is the text. So radar data dot transform dot location plus rear view. So we are getting the location and we are adding the rear view to and rear view is a negative value, so it will go back. Why do we add this minus here? You understand it now? And then we are going to set this text subscribe now, and lifetime will be for 0.06 milliseconds. I'll make it to zero point 0.1 and we'll see. But not for now, I'll just keep this 0.5, and we are setting the color equal to color dot color 0 210 258. It will give a sky blue color, and we are doing this code like almost 1 year, like not 1 year, sarcastically, like almost all the videos. And now, okay, why did I open this? Okay, I need cmd, yes, help.cmd. So this is a file I made. Okay, so color quality level low cd Python API cd. Okay, project code. Yes, Python project underscore something 207 to I think 217 that I don't think like I know it is. Okay, I'll just go this side. Yes, it's not happening. Yes, yes. Now enter, and you see the magic. Okay, where's the car? You see subscribe now, subscribe now. So like it has a lifeline. So you see it's moving with the car. So as we are keeping the lifeline like for like some milliseconds, and it takes a little time. Like you can say this is a work of lag. Like we are seeing so many of them, and you're seeing that the before ones which were created are getting erased and new ones are getting formed, and it can be seen from anywhere. So and it changes like its orientation according to it. So this is the power of world.debug. So now if we decrease the time, like if you wanted to learn a concept, it's done. So now we are going to do some experiments. So we'll just make this time so less, 0.01. Let's see what happens. So this class, like I'm saying it's a class. Yes, it's this video. We did not print anything. We are not studying about the data. We are studying about how do we create impressions. Now see, uh, you can see like it's like much less, but it's not pleasing to look at. So you know why I kept 0.5. Like it's pleasing to look at. So that's it for the video, friends. If you're liking this video, like this video and subscribe this channel. It's not a request, it's an order. You need to do it right now. And then share this video. Everyone should know about Carla, not only you. Why are you selfish? Be open. And with that said, we are going to end this video. Bye friends, meet you in the next video.